So, good morning, everyone. Tung, can you hear me? Okay, good. This week we have the class every day, right? We have Mondays, Tuesdays, Wednesday, Thursday, and also tomorrow morning, right? Tomorrow morning we will continue to study in linear algebra. Okay, yeah, I really hope you enjoy my class. Okay. Just relax, okay? Of course, when you study the undergraduate program or the university level, of course, we have some difficulties of the course. Okay, maybe you are not familiar with university study, but try to study hard. Try to discuss with TA. Try to discuss with your friends. Okay, to do homework. Yeah, to do exercise and yeah. I mean to study hard. Okay, is a good way. Okay, to be successful in the university. Okay. Okay, today we continue to study physics 1, okay, lecture 2, part 1, right? Okay. Okay, so for today, please help me to make a recording. Okay, we start the lecture now. Okay, so I will share my screen to all of you. Okay. Okay, so for now we continue to study lecture 2 part 1, and now we have some multiple choice questions, okay, at the beginning of this class, okay, today. So here the questions, which of the following is an example of uniform motion? Okay, we have a car going around a circular track. Okay, so at a constant speed. Okay, yeah, circular track. A person at a rest start running in a straight line in a fixed direction. Okay, yeah, in a straight line, yeah, in fixed direction, just fixed direction. Okay, yeah, they didn't mention about the speed. Okay, so yeah, we can ignore such question, such answer B. Okay, it's wrong because uniform motion. Okay, you need to uh, consider time interval and displacement. Okay, but now they just mentioned about the direction. Okay, not good. A pole drop from the top of a building. Okay, so we have the building, yeah, and we have a pole, yeah. It will drop from the top of the building. Okay, yeah, and we have a hockey puck sliding in a straight line at a constant speed. Okay, so now they didn't mention about the speed. Okay, so not good. So we can ignore answer B and answer C. Okay, so now we have two options, right? We have A and B. Okay, A and B. So for A, we have constant speed. For D, we have constant speed. But this one is circular track. This one is straight line. It's straight line. And you should remember for uniform motions, okay? So we have the same delta t with the same delta x, okay? We follow the straight line. So the good answer is uh, D, okay? D. Yeah, D. Okay. Yeah. Maybe we are considering answer C, but okay, they should mention about the speed. Maybe the pole trough, the top of the building, but different speed. Okay, different initial velocity. So we cannot consider. Okay, we cannot consider. And the key difference is here. Okay, for here we have the constant speed, but here is circular track. Okay, circular track, that means you have the this circular motion. Okay, two-dimensional motion, and here we have straight motion. Okay, so answer this is the most possible solution of these questions. Okay, then we have another questions. The area under a velocity versus time graph of an object is what? Okay, so here we have velocity, maybe Vx, and this is times. Okay, so we have a graph like this. Okay, so here we have ti initial time, here we have tf. Okay, so we can get the error here. Okay, yeah. So we have Vx a acceleration is dvx over dt. Okay, so that means right. So that means we have dvx over is dvx over dt is a, so dvx is a dt. Okay, yeah. Okay, so for that means when we take the iteration, you can get a vxe is right is the iteration is a, so here we should use vx. Okay, vx e dx over dt. Okay, yeah. So we should have the answer d displacement, right? Because yeah, I remember I explained to you before, right? We have dxe vx times dt. So we take the iteration here, the iteration here. We can get what? The iteration of the derivative of x. You can get x. Okay. So x is what? Here we get xi. Okay. For ti you have xi, and tf we have xf. Okay. So that means we take the iteration from xi to xf equal to this in time. So we have ti to tf. Ti mean initial times. Tf mean final times. Okay. Vx dt. Right. Okay. So ti we have xi, and tf we get xf. Okay. So here you can get xf minus xi, right? Okay. E vx times delta t. That means tf minus ti. So xf minus xi is delta x. And that is vx and tf minus ti is a delta t. Okay, what is it? This is displacement. Okay, so the answers will be D, the dimension about displacement. Yeah. Okay, so from yeah, if an object E speed it up. Okay, so we have three answers. Is acceleration is positive? Is acceleration is negative? Okay, is acceleration can be positive or negative depending on the direction of the motion. Of course, the question is the answer is C, because they just talk about the object is speeding up, the speed is increasing. Okay, so if you this is X, this is Y. If you stay here, okay, you can speed up, right? You can speed up in this direction, right? In this direction, you get positive, or you can speed up in this direction, negative. So positive is also okay, and the negative is also fine. So the good answers will be here is acceleration can be positive or negative depending on the direction of motion. Okay, continue. Okay, so we have yes some written questions, but you don't have more time, so skip it. Now we go to session 2.1. We discuss more details about the position, velocity, and the speed of a particle. Okay, so look, the position. Okay, a particle position x is the location of the particle with respect to a Gaussian reference point or reference frame. Yeah, we discussed before. Okay, any position of the object. Okay, you need to consider coordinate reference. Okay, xy, or normally it's xy coordinate. Okay, yeah, like this. Okay, so here is the position. Okay, so we have vector r. Okay, vector r. Yeah, so for vector r is position vector, and they just follow one direction, x-axis direction. Okay, so now we conclude that r is the position vector. Okay, or we can say a position is a vector. Okay, and of course r is a function of times. Okay, so you can use rt. Rt is mean the function of time. So the position is the function of times. Okay, and we just focus one dimension here, because lecture 2 part 1 we focus on one dimension. Lecture 2 part 2 we will focus on 2 or more dimensions. Okay, so yeah, so if we consider I overhead, okay, so you can indicate a vector r is a magnitude of r times I overhead. Okay, I overhead. So I overhead mean a unit vector of x-axis. Okay, and we also indicate the velocity vector. Okay, yeah, because we just follow one direction, right? So vector v and vector r have the same direction. Okay, because we only have one direction, right? Yeah. Now we try to indicate the curve of the position. Okay, or we can say the position versus times. Okay, so of course we have xy coordinate, so x will becomes times, okay, and y will becomes position x. Okay, so now if we observe this physical model, this is the starting point, because this is 0, right? This starting point. So this is y, this one is x. Okay, this is y, this is x. Okay, so if the car is at the location A, how many meter? Okay, I mean what is the displacement of position A with respect to the origin? 30 meter. Okay, so this is times. Okay, so for yeah, after 10 seconds, after 10 seconds, okay, yeah, at the beginning, right? At the beginning, the boy A, at the beginning, okay, you get 30 meter, right? Here, boy A, and after 10 seconds, the car will move from A to B, and the displacement is 50. Okay, so if 10 E, so it take 10 seconds, you get B here, okay, 50, 50 or maybe 50, yeah, 50. Okay, and continue. After 10 seconds, boy C, how many? Here, maybe 38. Okay, boy C. And next, after 10 seconds, okay, the car comes back to the origin. So you get 0. D at the point D, 30 seconds, you get 0. And after 10 seconds, you get a point E, maybe minus 38 here. Okay, and finally, after the 10 seconds, now we get point F, okay, far away from the origins, how many? Minus 55 meter. Okay, so you can draw the curve. Yeah, you can draw the curve of the position, right? Of the positions. Yeah, first times. Okay, yeah. So now x-axis becomes time axis and y-axis becomes displacement axis, okay, or position. Yeah. Okay. Continue. Sorry. Yeah. So again, you should remember, so when we consider any position, we need a reference frame, yeah, reference point, a reference coordinate. Okay, normally we choose xy coordinate. Okay, so if you don't want to use the curve, I mean the graphical representation, you can use tabular. Okay, you can use a tabular representation like this. Okay, so we have three columns, right? We have position, yeah, we have times, and we have displacement x. Okay, so how many positions do we have? A, B, C, D. So we have 6. Okay, 1, 2, 3, 4, 5, 6. You get A, B, C, D, E, yeah, F. Okay, yeah. And then we have the time interval, right? The time interval is constant, right? Yeah, every time interval between one point to another point, 10 seconds. Okay, so just 10 seconds. So at the beginning you get 0, right? Yeah, remember that. Okay, at the beginning, the initial times will be 0, 0, 10, and 20, 30, 40, 50. Okay, yeah. So if it's 0, you can guess XA 30 and so on. Okay, so it depends on you. Okay, you can use graphical representation. Okay, and this is times, this is position, or you can use a tabular representation. Okay, with 3 columns: position, times, and displacement. Okay, and displacement. Okay. So from now, we need to classify between displacement and distance. Okay, so very easy. When we consider or determine displacement, you need to have the coordinates frame. Okay, the coordinate system like this. Okay, y, x. Okay, and then we will consider initial position xi and if a final position xf. After that, you take difference between xf and xi, you get displacement. For example, here, yeah, from here, and the ti, ti mean initial position. Okay, so at the ti we have xi. For example, here starting time, this is ti is 0, right? And xi is 0 also. Okay, so after some times, okay, he moved from the starting point to the end point. Okay, this is tf. So after tf, for tf he gets xf. Okay, yeah, so xf is how many? This is x, this is positive, negative, positive, negative. Okay, so okay, so here they can get some, you know, xf. This is xf, right? So this is xi. So we have delta x is xf minus xi. This is displacement. Okay, right? The destination point here. Okay, so you can get here is xf. Xf minus xi delta x. So now distance. For distance, we don't care about coordinate. Okay, we don't need coordinate. Yeah, we skip coordinate. Okay, we just measure the length of a path he follows. Okay, so yeah, you measure the length of the path. Okay, yeah, you can get a distance. Okay, yeah. So in summary, for distance, we don't care about coordinate. We don't care. Okay, we just measure the length of the path. Okay, you can get distance. So if we consider displacement, we need to use reference coordinate. Okay, and you need to determine xi and xf. Okay, and then you take the difference. Okay, you can get displacement. Okay, any questions so far? Let me check. Oh, we don't have okay, we don't have actual point. Okay, at the beginning of the lectures. Okay, sorry. Okay, so continue. Yeah. Now look how to represent the position. Okay. Yeah, I mentioned before it depends on the xy coordinate, right? Okay. The origins will be here. Okay, and the position here, so x is positive. Okay, the origin here, right? This is origin, and the position at the left side, so this x is negative. Okay, the origin is here, and the position is here, so that means it's positive, right? Minus minus the infinite. Okay, so this one is positive infinite, negative infinite. Okay, so if the boy here, does mean y is positive, and the position here, the boy is here, so y is negative. Okay, so that is the reasons I mentioned to you. If we have xy coordinate any position here or here or here or here, you can know x is positive or negative and y is positive or negative. Okay, yeah, and remember you need to follow only one direction, or x either the direction or y direction, because we are considering the object moving in one direction. Okay, yeah, but next lecture you need to consider both. Okay, you need to consider both of them, x-axis and y-axis. Okay, so from here, yeah, we have graphical representation, right? Okay, the time is 0. The time is 0, and then yeah, after 1 minute they get maybe 60 meters, 2 minutes get here. Okay, at 3 minutes, 4 minutes, 5 minutes, okay, 6 minutes, okay, 3, 4, 5, 6, 7, 8, 9. Okay, so you can see from 0 to 1, okay, 1 to 2, 2 to 3, you know, the distance I mean the displacement, okay, here, okay, this is 60 meter, and here displacement, you know, when we consider displacement, you need to compare with the origins, okay. So now this is 100, maybe 20, blah blah blah, okay. So you can draw the curve like this, okay, yes, and the x-axis is times y-axis is the position, okay. So this one is non-linear curve, okay. Yeah, this is graphical representation. Okay, of course, we can use tabular representations. Okay, here this is times positions. Okay, yeah, and continue. Okay, 0, 1 second, 2 second, 3. Sorry, minute. Okay, so sorry, minute. Okay, 1 minute. Yeah, 2 minutes, 3 minutes. Okay, 4, 5, 6, 7, 9, 8. Okay, and you have the position. Okay, yeah, position. Now we talk. So now we already understand what is the difference between displacement and distance, right? Okay. Yeah. Now we understand what is displacement of the object. Okay, and distance. Okay. So the key difference is that displacement use reference axis, and distance just measure uh, the length of the path. Okay. Now we continue. What is the average velocity? Okay. So now the average velocity is we use v over bar. V over bar means average, or we just say v avg. Avg mean average. Avg average. Avg. Avg. Okay, so the average is defined by the ratio of displacement to time interval. Okay, yeah, time interval. I overhead. Okay, yeah. Here is the definition of average velocity. So delta x is what? Delta x is xf minus xi, and delta t is tf minus ti. Okay, I overhead. So sometimes they don't use f and I, they use x2 minus x1 and t2 minus t1. I overhead, that's okay. That's okay. But normally we don't use x2, x1, t2, t1. We use xf minus xi, tf minus ti, I overhead. Okay. So continue. If ti is 0 and xi is 0, you can guess average velocity is xf minus tf, I overhead, right? Because this one is 0, 0. Okay, this is special case. Okay, because normally we have ti and xi are on 0 at the beginning, at the initial point. Okay, so we can get this one. But for general formulas, we have average velocity is xf minus xi divided by tf minus ti is I overhead. Okay, you can get a average velocity. Okay, yeah. And then here we have Vx average, okay? E delta x over delta t, this is a vector, okay? This is a vector. So here x is what? X, sorry, average. So x mean we follow x-axis direction. And then average mean we calculate the average velocity. Okay, so you get delta x over delta t. Okay, because they have the same direction, right? With the same direction, so we can say delta x over delta t is I overhead. Okay. Next, yeah, example. Okay, I would like to calculate the average velocity. The average velocity of the car between point A and point B. Between point A and point B. Okay, position A and position B. So that means position A is initial position, right? And position B is final position. Okay, so we have Ti is what? A, Ti is 0, and Xi is what? 30, right? And for the final position, we have Tf, how many? Point B, 10 seconds. And Xf, how many? 52 meter. Okay, so we have V average. Okay, yeah, you can use V over bar or we can use Vx average. E what? E delta x over delta t, I overhead. Okay, so delta x is what? Xf minus xi, you get 50 minus 30, you can get 22. And here you get a 10 minus 0, you get 10. So you can get 2.2 meter per second. Okay, so this is the average. This is the average velocity. Okay, the average velocity is 2.2 meter per second. Yeah, so for example, if I would like to calculate the average, okay, uh, between point, point, point D, point D and point E, okay. So now for point D, we have Ti is what? 30 seconds and Xi is 0 meter. And point E, it is final position, right? So you get the TF is 40 seconds. And XF is minus 37 meter. So now you can get V average E XF minus XI, you get minus 37 divided by TF minus TI, you get 10, then you get minus 3.7 meter per second. So if now you look, okay, and of course we know velocity is the vector, so for point A and point B, okay, the velocity direction like this. Okay, so from point D to point E, the direction of velocity like this. Okay, because this is x-axis, this is y-axis, so the velocity will be positive, positive, and now they follow the left side of the x-axis, so this is negative, negative. So now you get minus 3.7 meter per second. This is correct. Okay, any question, please? Okay, maybe I will double check at the chat room whether we have the question or not. So if the graph below TS6, VT graph, the areas will be negative. This is illustrating the displacement. You know, for the areas, you know, the areas will not be negative. Okay, the areas, you know, areas is always positive. Okay, yeah. This area, you know, square, so this is always positive. So from, yes, of course, for displacement, we also have positive and negative also. Okay. Is it clear for you? Have you got it? Okay. Yeah, as I mentioned before, you know, if we consider reference coordinate, Okay, displacement maybe is positive, maybe negative. It depends on the direction of the object. Okay, yeah. But why the obvious examples is the displacement? What is this reverse example? Which slide? Hmm? Let me. What's the what is examples? You mean this example here? Okay, yeah. You know, because uh, we have the coordinate here. Okay, yeah. So for boy 8, boy B, boy C, and boy D, yeah, that is E that they are in the right side, right? In the right side of y-axis. So x is always positive. Okay, it's a positive x. And at the left side, you can see, um, okay, because this is zero. So if here is displacement, okay, if here is displacement, sorry, if here is position, so this is negative, negative, negative. So now, okay, this is the time, right? Now this displacement is y-axis, so you get a negative. Okay, yeah. So if you get delta x is negative, that means we make the reverse direction of the motion. Okay. Yeah. No. You just ask TA if you don't understand clearly, it's because I seldom relay the emails from students. Okay. Yeah. Okay. So for continue. Now we compare the speed and velocity. Okay, so we need to look the definition. The average speed. Okay, we have average velocity, right? So average velocity we say is v x average. Okay, is equal to delta x over delta t. Okay, yeah. So we have average speed. Okay, average speed we just say v average. Okay, we don't have x. Okay, why? Because x means direction. X means direction. So if we don't have x, we don't mention about x. Okay, so just average speed. Okay, so average speed e divided by distance over uh, over times. Okay, distance with respect to times. Of course, here they say delta t. That means you need to remember that's ATF minus Ti. Okay, so the average speed of a particle, this is a scalar quantities. Okay, yeah, this is scalar quantity. So that means they just consider the magnitude. Okay, E is define the total distance. D travel divided by the total time interval required to travel that distance. Okay. Anyway, you take the ratio of distance with respect to times. Okay, that's on. So now we also study displacement, right? Okay, what else? Distance. What else? average velocity, we say Vx average. This is direction, this is average. We have V average. This is speed. Okay, average speed. Okay, now we have four, right? Displacement, distance, um, average velocity, average speed. And of course, we know for average speed is d over delta t, average velocity is delta x over delta t. Okay. So for any questions so far, let me check. Okay, good. Continue. But now for just review, remember that the average velocity is the vector, and the average speed is a scalar quantity. Okay, no vector. Why? Because when we consider distance, for example, this is x and y. When you start here, right? When you consider the distance, this is initial position. This is final position. Okay, we don't care about x and y axis, right? We just measure the length. Okay, so if we don't have coordinate, okay, if we haven't considered coordinate, that means we don't have the vectors. Okay, any vector we should use the reference frame, the reference coordinate. So if we have no coordinate, okay, so of course the average space must be scalar quantities because no reference frame. Okay, distance over the times. Okay, so here average space the distance over times and average velocity, the displacement over times. Okay, so remember, okay, I mentioned again. So delta x is xf minus xi. We don't care xf higher than xi or xf less than xi. We don't care. We don't care. If xf higher than xi, you get delta x is positive. Okay, that means follow positive direction, right? X. So if xf less than xi, that means delta x is negative. You get reversed direction. Okay, we don't care about the values of delta x. That is positive or negative. Okay, we don't care. But if positive, follow one direction and negative, okay, reverse direction. Okay, that is the meaning of displacement. Okay, to help us determine the direction of the object, the direction of the motion. Okay, for example, okay, so one more example. So if we have a position A, okay, position A, okay, position A stay here, okay, and then this is Y, this is X, and then they look at the the motion of the object. This is the object, okay, object here. And if he observes the object, okay, and then you can see, he can say that, okay, the object is moving follow x-axis direction. This is R is positive, right? R is positive, okay, and V is positive because he stay here. He stay here, okay, yeah. So that means we consider the objects with respect to the object's motion with respect to the xy coordinate. Okay. Yeah. And here this is xi. Here somewhere here should be xf. Oh, and then we have another guy. Here is position B. This what? This is x. This is y. Okay. So now he stay here and observes the object. Okay, so he can recognize that the object is negative, right? Position. Okay, so here is xi and here is xf. Okay, so xi is negative, xf is negative because he stay here. He had the reference axis, reference coordinate here, and then he observed the objects. Okay, so that means xi is negative, xf is negative. Now we have delta x is xf minus xi. Okay, xf is negative, so maybe here is okay, here is 0, so here maybe minus 50. Okay. Okay. Oh, sorry. Yeah. But anyway, you can yeah, you can analyze the displacement, okay, with any random reference coordinates. Okay. So we review. Okay. Look, motion as a constant speed. Okay, in a straight line is called uniform motion. Okay, we have two ideas. The first one, constant speed. The second one, straight line, straight motion. For example, like this. Okay, this is x-axis, right? This is x-axis. Okay, so we have the constant speed. Okay, so we know how to calculate the speed, right? Okay, we have average speed v average e, okay, d over delta t. Okay, yeah. They just say it's constant speed and maybe instantaneous speed or average speed. Okay, so if we consider average speed, we can get d over delta t. So here is delta t. Delta t how many? 20 seconds. Sorry, 1 second. Sorry. One seconds. Okay, they get 20 feet delta t. D. Okay, and then from 1 second to 2 seconds, the distance is also 20 feet. Here 20 feet. Okay, so the same time interval, the same distance. So this is uniform motion. Or here in the car, okay, the interval time is 1 second. How many feet? 40 feet. And next 1 second, also 40 feet. Okay, so car and the bicycle have the uniform motion. Is it clear for you? Any questions so far? Okay, so we continue. Okay, look, you know, of course we have the definition, right? Average velocity, Vx average E, remember x mean the direction, equal to delta x over delta t, or delta x over delta t I overhead. Okay, look at this one. Bike one, you stay here, right? You stay here, so the reference axis will be here, x, y. Okay, so when we observe the motion of the bike one, we get the delta t is positive and delta x is positive. Why? Because if the time interval is 1 second, you get how many feet? 20 feet. Okay, next 1 second, 20 feet. Okay, so this is a uniform, right? This is uniform motion. Okay, and we know the object is moving to the right side, and now this is you stay here, right? You stay here because this is 0 seconds. Okay, this is x, this is y, so that means by 2 has the opposite direction with by 1. Okay, yeah. And what is the velocity? What is the average velocity? So average velocity is delta x how many? Delta x, You get 20 feet, right? Over delta t how many? 1 second. So you get 20 feet per second, right? Yeah, this is magnitude. And then if we consider the vector, so this is 20 I overhead feet per second. And how about by 2? By 2, we have Vx average is minus what? Minus 20 I overhead feet per second. And then if we don't care about the graphical representation, I just consider this one and this one. I can know by 1 and by 2 have the opposite direction because this is positive, okay? Positive 20I overhead, this is minus 20I overhead, okay? So they are in opposite direction to each other, okay? Yeah. Continue, okay? So now we calculate what? We calculate displacement, average velocity, and average speed between point A and point F. Okay, point A and point F. Okay, now displacement. So now we have point A. That's mean initial point, right? Between point A and point F. So initial point. Okay, so TI how many? Point A. TI 0 and XI how many? XI 30 meter. So point B, this is final, sorry, not point B, point what? Point F. So this is final point. So TF how many? 50. And XF how many? Minus 53 meter. Okay, so we need to analyze initial point and final point. So now we calculate displacement. Okay, this displacement means delta x is xf minus xi. Xf how many? Minus 53. Xi how many? 30. So that means you can get minus 33. Yeah, 83. Okay, this is 53. Yeah. Okay, you get 83 meter. Okay, so this is displacement. Okay, now if we calculate the distance between A and F. Okay, so that means you need to calculate distance plus distance plus distance plus distance. Okay, yeah, you can get later on. So we have distance, I hope. Okay, so now we calculate average velocity. Vx average is what? A delta x over delta t. Delta x how many? Minus 83. And delta t how many? Tf minus ti, you get 50. Okay, so now we have 83 divided by 50. You get minus 1.66 meter per second. Okay, that means after some time, the direction of the car will be reversed. Okay, yeah, because the velocity is negative. Okay. Yeah, so actually you just say V average is minus 66 I overhead. Okay, meter per second. Okay, so yeah, minus 66 means minus 1.7. Now I would like to calculate the average speed. If you would like to calculate average speed, you know we have V average. Okay, we don't have X. Okay, yeah. Now you compare here. This is Vx average. This is V average. Okay, to no direction here. Okay, so is what? E d over delta t. Okay, d mean the distance between A and F. Okay, so how can we know? We know distance. Okay, so the distance from A to F, that means we have D, right? We have the distance between A to B plus the distance B to C plus the distance C to D plus the distance D to F, D to E, and plus the distance E to F, right? Like this, because we need to measure this length. Okay, so but this is non-linear. Okay, this is non-linear curve. So when we calculate distance, we assume, okay, we assume this is linear curve. I mean, you get this one plus this one plus this one plus this one plus this one. Actually, when we measure the length, this is non-linear. This is the curve, not the line. Okay, but we assume, okay, you can guess approximate straight line. Okay, yeah, so for easy. But actually, you need to measure. So if we measure this curve, okay, maybe it's difficult, a little bit difficult or complicated. So we just assume this curve to becomes the linear curve. Okay, so if you assume that, okay, you can get the A to B. Distance between A and B will be how many? 50 minus 30. You get how many? Maybe here I have some. This is 22. Yeah, 50 minus 30, you get 22. Okay, and then 30 to 52, you get 14. Oh yeah, we don't care about. We don't care about positive or negative result, because the distance no coordinate. That mean okay, we don't care about positive or negative. Okay, so 38, 0 and 38, you get 38, and 0 to 37, you get 37, 37 to 53, you get 60. Okay, so when we calculate sum of them, you get 127 meter. Okay, and then you can get the average, a 127 meter divided by from TF to TA, you get 50 seconds. Then you can get 2.5 meter per second. Okay, this is the average speed. Any question, please? So far? One minute for questions. And you don't understand? I hope we have some questions. No questions? Any questions? Don't be shy. Just ask me. I will explain to you. Okay. Yeah, or that means here you take the absolute, because the distance will be positive, not negative. Okay, so you get here. Okay, now you understand how to calculate displacement, distance, average velocity, average speed. Okay, so continue. 2.2. We discuss about instantaneous velocity and instantaneous speed. Okay, yeah. Vietnamese meaning is vận tốc tức thời, tốc độ tức thời. Okay, so often we need to know the velocity of the particle at a particle instant in time t. rather than the average velocity over a finite time interval, delta t. Okay, or you can say that if we have Vx average, that's a delta x over delta t, right? 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 I overhead, right? So for delta xe, xf minus xi, and delta te, tf minus ti. Okay, I overhead. So if tf nearly equal to ti, that means just tf, that tfe, tfe that means TFE TI plus delta T. Okay, so if TFE 0.001 and TIE 0.000, okay, this is 0 second. Okay, and this one is 0.1 millisecond. TF is very small in comparison with TI. Okay, so that means delta T is very small. So delta T is approaching to 0 if TF equal to TI. But of course, TF will be will not be equal to TI, but TF is very small. So if TF is very small, now okay, you can get Vx average A delta x over delta t. I already. So if delta t is 0, okay, if delta t is exactly 0, we don't have Vx average. We don't have. Why? Because if we divide this by 0, no meaning, meaningless, right? Meaningless. We cannot divide it by 0, and we don't know 1 over 0 is what. Maybe it's to approach infinity. So to answers, okay, to find the solution of this issue, they define limit, right? You study limit from the high school, right? So now if delta t is approaching to 0, of course not equal to 0, just approaching to approximately 0, you calculate Vx. Now Vx average become Vx, okay? Okay, why? Because if delta t is approaching to 0, that means we consider only one point of times, okay? A point of times, or we can say instant times, right? Instant time. So now if delta t is approaching 0, we can get instantaneous velocity. So now if we see Vx, okay, we don't have V average, so that means this is instantaneous velocity and equal to limit delta t is approaching 0, delta x over delta t. Okay, this one you studied from high school, right? Any questions, please? Okay, so now when we calculate the average instantaneous sorry, if we when we calculate the instantaneous velocity, that means delta t is approach to 0, we take the limit, okay, of this ratio delta x over delta t. Okay, yeah. Or here Vx equals the limiting values of the ratio delta x over delta t as delta t is approaches 0. Okay. Or you can say the Vx is the slope, of this line tangent to the x versa times. Maybe I will explain to you. Okay. So now look. Uh, this is x versa time, right? Yeah. Position versa times. This is non-linear curve, and for t at point A you get ta is 0, right? And at point B you get tbe 10 seconds. Of course, 10 seconds is much higher than 0. Now, if I shorten the times. Okay, so delta delta TA TB minus TA. So now if I shorten, if I try to shorten the times, that means I move point B here. I move point B to be near to point A. That means delta T is approach to 0, right? At the beginning to be here. Okay, so when I shorten the time, so maybe TBE 9 seconds, TBE 7 seconds, blah blah. So if TBE 0.00001, something like that, TB. So that means B point B here will move to be near point A. So you can get, so if delta T is small enough, okay, so A will be coincide with the B. Okay, and then you can draw the tension line. This is tensions, right? Tension line. Vietnamese meaning đường tiếp tuyến. Okay, tension line. Okay, so the tension line mean the instantaneous velocity. Okay, of course this is a vector with the v. Okay, so if we consider instant time TB, you get this slope here, right? So this is velocity, instantaneous velocity is point B, point C, VC, VD, VE, VF. Okay, so this is instantaneous vector. I hope you enjoy it. Any questions so far? No questions? Okay, so I will ask someone. Lê Gia Bảo, any questions from you?
No.
Yeah, we have some noise. Okay. Yeah. Okay. Continue. So later on, the TA will randomly check your attendance. Okay. Now continue. So yes. Okay. Yeah. Tension line. Okay. Yeah. Okay. Yes. Tension line of point C. Tension line of point D. That means the instantaneous velocity at point D, instantaneous velocity at point E, instantaneous velocity at point F. Okay, so now look, I give you more example. Okay, so now if we have y and x axis, y axis, this is time t. This is x position. Okay. So we have the curve like this. Okay, the curve like this. This is a position curve. Position curve. Position curve. And I will consider this point. This point. This point. Okay. Yeah. And maybe this point. Okay. So it is point A, is point B, into point C. So you can get the instantaneous velocities at point A, right? Okay, so this is the instantaneous velocity. Okay, this is the tension line, right? The tension line. This is the tension line, right? This is the tension line. Okay. Okay. So look, if I move this vector to be here, you can get the slope is positive. The slope is positive. Why? Because the slope E delta x over delta t. This slope, right? Attention. Delta x over delta t. So because if we follow this this one, that means xf higher than xi, and the tf of course higher than ti. So this is positive. So you get slope is positive. Now we consider this one. Right? So we consider this one, and then we move to here. The same, right? The same. I just let the tail of the vector to be here. You can get here. So the slope is negative. The slope is negative. Why? Why? Because at this point, you get xi here. That's about somewhere here. You get xf here. Okay. So xf less than xi. So we get this slope. Delta x over delta t is negative. Yeah. Yeah. So that means the velocity will be changed. Okay. The direction of the velocity will be changed. Okay. So that means here this is the first current, the second current, the third current, and the fourth current. So we only consider two current here and here. Okay. We don't care about for minus infinite, because normally for one direction. Okay. So for one direction, for one direction. For one direction, because this is zero, and if we follow this one, right? If we follow this one, that means the position is always positive. The position, the position is positive, so that means we only consider the first current and the fourth current. Okay, and if this case occurs, you get slope is positive, and now for this case, you get slope is negative. Similarly, if we move to the negative direction, that means the vector r, okay, E at the left side. Okay, so here the second current is positive, is negative, and this one you get a positive. Okay, for example, now we have the curve like this. This is y and this one is x, and this is positive, right? It's negative. Okay, so you get the curve like this, right? Like this. So this is point A, this is point B, this is point C, something like that. Okay, so because we consider the negative direction of the position, okay, of the x-axis, so you can get the tension line like this. Okay, tension line like this, tension line like this. Okay, yeah. So this one like this one. Okay, yeah. This is time, right? This is position. So if now we calculate slope, slope is delta x over delta t, right? So delta x is positive. Delta t is delta x is negative. Let me check. Okay, let me check delta x is positive, right? This is x, this is time. Okay, time. So delta x is, this is xf, this is xi, so xf higher than xi, this is, but delta t is in negative because this is ti, this is tf, and ti and tf all negative, right? So for example, for tf is minus 5 seconds, this is minus 2 seconds, So to F unattended is negative. Okay, so you get slope in negative. And similarly, if boy C, I move to here, you get slope is positive because delta X is negative and delta T is also negative. So negative over negative, you get positive. But you should remember for the meaning of the practical application, okay, we will forget the negative times. Okay, we forget it because this is negative time. Okay, we just consider as positive time. But if you go to the second year, the third year, sometimes we also consider negative time. Okay, and why we consider negative time? Please ask the lecturer to cover that course. Okay, now this is outside of the scope of this course, so I cannot mention. I will not mention more details about what kind of application we use the negative time. Okay, yeah. So please remember in your mind, and if you go to the second year to the third year, you ask some lecturer why we consider negative time. Okay, or if you study electric circuit, and let's say it's covered by Dr. Udo, maybe you ask him why we consider negative time. So, or here, if this is time, this is 0, so we have t0 plus and we have t0 minus. T0 minus mean negative time, and why we consider is, okay, so yeah, he will explain to you. Okay, but now, yeah, I just opened your mind. Okay, think about some application with positive time, some application with a negative time. Okay, yeah, that's all. So, any questions so far? No questions? Maybe you can give me, okay, you imagine what kind of application we use negative time, okay, and tell me, maybe you get some extra point. Okay, just type some messages in the chat room, and I can read, okay, your sentence. Okay, maybe 1 minute, think about it. Okay, maybe I guess some example. Time travel. And not so clear. Think about electrical and electronic application, not common applications. Okay, think about the circuit. Think about any electrical or electronic device. Okay, or you can ask ChatGPT. Okay, or here you can ask ChatGPT what are the electrical and electronic applications to use negative time. Okay, and yeah, they will give you some interesting ideas. Okay, so I think we take a break, 10 minutes now. Okay, before we continue. Okay, so now the time is 10:27, and you will come back at 10:40.